Hello, my name is Daniel Buckholz, and this is my Unit 4 presentation for my UMGC Data 625 Data Visualization course. I chose to focus on US emissions versus population and GDP growth over the period of 2010 to 2020. I wanted to see how the predictions from this time period stacked up to the observed reality over the last 5 years. As someone with a background in environmental sciences and an intention towards environmental analytics post-masters, I felt that this would be a great opportunity to test both my environmental science knowledge and my use of Tableau's predictive features. To begin, I looked at the US population over the period from 2010 to 2020 and the predictive line drawn from this time period. As seen, US population has continued to increase from the start of the 21st century and is predicted to continue doing so over the next few years. This has indeed come to fruition. However, comparing the prediction that Tableau made to where the current US population stands, we actually have seen that it is about 20 million people lower in reality than where our median prediction was. However, this still falls well within Tableau's predictive cone. Continuing from here, I found a similar trend with the US GDP over the course of the last roughly 15 years. GDP has continued to trend upwards from around 15 trillion to around the $25 trillion mark. This fell well within the expectation that Tableau put out with its predictive cone, and we have seen that these trends are very strongly correlated. In fact, when we draw a linear regression line, we can see that they have a p-value that is well within statistic importance. This incredibly low p-value shows us that there is indeed a statistical significance between these two variables and that one can be used as a great predictor of another. However, we have also observed that over that same time period, our net emissions have dropped, which is predicted by Tableau to have smoothed out over the next few years following this dataset. In fact, we have seen that these emissions rates have dropped even further than expected in the United States since 2020. However, in correlating population to kilotons of emissions, we see an interesting trend. One would expect to see that as population increased, emissions increased at a consummate rate. However, in the United States, due to both a greater focus on environmental priorities and a higher GDP allowing more resources to be allocated towards these priorities, we have seen that even though the population has gone up, our emissions rates have gone down. The R squared and p values for these do show a relatively decent connection on a social level. However, scientifically, neither of these two values would be quite strong enough to draw sound conclusions. For this final graph, I felt that the most appropriate predictive line was to use an exponential trend line. I found that due to the high variance between data points, using a linear trend line was not appropriate, and in fact, a exponential line would likely predict a similar trend to the data shown. So, in summary, despite population and GDP growing at consummate rates to each other, our CO2 emissions rates in the United States have continued to decrease over the last 15 to 20 years. With a greater focus on environmental policy and more resources allocated towards enforcement and research of those policies, we can continue to bring down our emissions rates and support green initiatives.